6 is officially its theorems about roots of polynomial equations. So we're still studying polynomials. We're still thinking about their graphs. And we started last time, we're still thinking about their solutions. Okay, where do they cross the x-axis? What kind of solutions do they have? Now, with that all said, the first thing we're going to talk about today, is the rational roots theorem. And it says, given a polynomial, all possible rational roots. So you'll hear me refer to these as PRRs. Okay, so all possible rational roots can be found by taking factors of the constant coefficient, which we refer to as P, divided by, and then it's factors of the leading coefficient, which we refer to as Q. And so you put these together as a fraction, and all of our possible rational roots can be found by doing P divided by Q. Okay? So that's what we're looking at. We're looking at finding possible rational roots. In other words, we're going to find more possibilities than what actually work. But we're going to find a list of possibilities that we can then use on this next set of problems to find the ones that actually work. Okay, so I'll explain that more later. But we're going to start by figuring out our PRRs. Okay? And I'm going to set that up by saying x equals P over Q on this first example. Now, go back up to the directions. X equals P over Q. What did it say P represents? Factors of the constant. What is my constant in this problem? Which value is the constant? What'd you say? No. X would be our variable.
-8.
Okay. -8. Why is -8 our constant? Okay, because it's the one without a variable. Okay. So on top of my fraction, what I'm going to work out here in a moment are factors of, and officially I'm going to say factors of -8. I'll be honest, it's not going to matter either way, whether you say +8 or -8. So it's going to be factors of -8. That is the constant because it is the number without a variable. Most often at the end, right? And then denominator. What's Q? Okay, it's factors of the leading coefficient. So my lead term is 4x to the 4th. The leading coefficient is the 4 out front, yes? So that is my leading coefficient. And that means on bottom here, we're going to be doing factors of 4. Okay? So factors of -8 over factors of 4 is what we're looking at. Okay, let's make a list. On top, factors of -8. What kind of factors of, and I wouldn't even worry about negative right now, just think 8. What kind of factors of 8 can we talk about?
2 or 4.
Okay, 2 times 4 is 8, yes? So that's a pair of numbers. What else can we talk about? 1 times 8 is 8, yes? Okay, so 1 and 8, 2 and 4. Are there any other ways to multiply to get 8? No. So my factors are 1, 4, 2, and 8. Now, here's the catch. Or not catch, but the key. I am going to throw in front of each of these a plus or minus, because here's the deal. Officially, it's multiplying to be -8. Well, how do you multiply to be a -8? Positive times a negative, right? Now, when we get down here to a positive, how can you multiply to be a positive? You can either do 2 positives or 2 negatives. So, with that in mind, so my factors of 8, I'm going to say plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Okay, so we're always going to put, with these factors, we're always going to put plus or minus in there so we can include both. But it's 1, 2, 4, and 8. What about the denominator? What are factors of 4 options? 2 and 2. What else? 1 and 4. So 1 and 4, 2 and 2. So when I list that, I'm going to list it as 1, 2, and 4. I'm not going to list the repeat. So I'm going to say plus or minus 1, plus or minus 2, and plus or minus 4. Okay? And by all means, you get into the bigger numbers, you need to grab the calculator, do it. Okay? Now, we're not going to leave our answer just like this. Okay? We know the possible factors on top. We know the possible factors on bottom. What we're going to do for our final answer is we're just going to come up with a list of numbers, which means we're going to pair these up essentially. So I like to be organized about it, and I like to go through and say, okay, I'm going to take turns putting everything in the numerator over each denominator. So I'm going to go through and put everything in the numerator over 1. Then I'll repeat the process, put everything in the numerator over 2. And then everything in the numerator over 4. So let's start with everything over 1. What is 1 over 1? 1. So I'm going to say plus or minus 1. 2 over 1. What is 2 over 1? So plus or minus 2. 4 over 1 is 4. Plus or minus 4. What about 8 over 1? Plus or minus 8. So I've gone through and put everything from the top over the 1. Repeat. Everything over the 2. What is 1 over 2? Okay. Plus or minus 1/2. What about 2 over 2? That's 1. Do I already have that listed? I do, don't I? So I don't need to relist the number that's already there. So 2 over 2 is 1. I've already got that. What about 4 over 2? That's 2. Do I have it? We already have it. What about 8 over 2? No. 8 divided by 2? It's 4. Do we already have it? We do. Okay, so everything over 2, that's accounted for now. Now we're going to take a turn and put everything over 4. What about 1 over 4? That's going to be plus or minus 1/4. What about 2 over 4? 2/4, which reduces to 1/2, so I don't need that. What about 4 over 4? That's 1. We've already got it. What about 8 over 4? That's 2. We've already got that. So my list of PRRs are this list of numbers right here. Plus or minus 1, 2, 4, 8, 1/2, and 1/4. Okay? And so as long as you can get all your factors written down, it's not a hugely demanding task. You'll always want to, when this is what's being graded and what you're being asked to do, you'll always want to go through and make an actual list. Don't just stop up here. I know all the information is up here, but we need a list. Okay? Now, when you do this for me, like on a test or something, this is what I'm going to recommend writing out. Okay? Make use of that plus or minus sign. When you go into homework to do this in Savvis, okay, here's going to be the deal. First of all, good news, I think, they make it multiple choice. So you don't have to type all of these out. Okay? The other thing they do, which is kind of weird, but it works for them, is they don't use the plus or minus sign. So Savvis, their list would be 1, comma, -1, comma, 2, comma, -2, comma, 4, comma, -4, comma, 8, comma, -8, 1/2, -1/2, 1/4, -1/4. So they'd have the whole list without a plus or minus sign. Okay? Now, I'm just telling you that so you're aware. The key will still be making sure you have all the right values. Okay. Question here. Okay, let's try this other one before we move on to the next piece. Okay, so we have a new equation on example B. And again, we're being asked for our potential or possible rational roots, PRRs. So Officially, I'm going to say P over Q. What about P? What goes on top? Okay. Factors of the constant, which is right here. So factors of negative 45. And it's not even that the negative is that important. It's mostly important that you get the 45. What about the denominator? What about Q? It's going to be what? Okay. Factors of the lead coefficient, which right here, which is the 7. So in my denominator, I'm going to be talking about factors of 7. Okay. How confident are we? Do we know these? Factors of 45. What's an obvious set to get started with? Okay, 1 and 45, yes? So if I say 1 and 45, I'm going to go ahead and write down the 1. Now, because I like to put them in order, I personally am going to just kind of hold the 45 in my brain. If you want, could you put the 45 down at the other end? You can. Okay? Now, you may or may not have another pair in your head, but I want to be organized about this. Because here's the deal. 45 is one where it's easy to miss some. So we use 1 in 45, right? After 1 comes 2. Does 2 go into 45? No. 2 is even. Is 45, or 2 is 2. Is 45 even? No, 45 is not even. So is it going to divide by 2? No, so 2 doesn't work. Okay, what about 3? Does 3 go into 45? Yeah, it's 3 times what? 15. Now, again, personally, I'm writing down the 3. I'll come back and get the 15 later. If you feel better writing it down now, go for it. Okay, after 3, check 4. Does 4 go into 45? No, and here's the clue, guys. Did 2 work? No. And if 2 didn't work, no other evens could possibly work. By 2 not working, we have knocked out all possible evens. Okay, so 4 doesn't work. What about 5? Yeah, 5 and 9. So I'm going to write down my 5. Okay. I'll come back and grab the 9 here in a moment. After 5, what about 6? No, I just said 2 didn't work, so no evens work. So 6 is out. What about 7? We want it to work, but it doesn't, does it? Okay, 7's a no-go. What about 8? It's even. It can't work. What about 9? Didn't we already mention 9? It goes with 5, right? So plus or minus 9. And at this point, what that means is I've gotten half of every pair, right? So 5 and 9. What went with 3? 3 and 15. And 1 and 45. I'm just trying to give you ideas of how can we do this and make sure we get all of them and not overlook any. Okay? What about my denominator? What about factors of 7? 1 times 7. Anything else? Not officially factors because factors are defined as whole numbers. So nice thought, but yeah, there's no other whole number factors, right? So 1 and 7. 7 is what I would classify as a prime number because its only factors are 1 in itself. Okay. As much as I'd love to say, okay, let's just leave this as an answer, we need to be official here. So go through and write out your options. I'm going to start like I did last time. I'm going to start by putting everything over 1. So 1 over 1, 3 over 1, 5 over 1, 9 over 1, 15 over 1, and 45 over 1. And keep going. Now put everything over 7. Keep going. I feel like I would probably have to look and see what she did to know. Because I have 1 and 8 working out instead of division. Unless maybe she misread her graph and grabbed 2. I might suggest that she go back, because once she lists the PRRs, I might suggest she go back and like check the graph and make sure that when she grabbed 2, you know, that it was actually, my guess is it was probably 1 and not 2. Or if her graph is really showing 2, did she type it right?
Okay.
Those would be my thoughts. And past that, I'd have to look and see what her work is and where it went astray. Does that make sense?
Yeah.
Okay. Okay. Did you guys finish this? I gave you directions this time, yes? My nosy butt class, right? Okay, what do we have? 1/7, 3/7, 5/7, 9/7, 15/7, and 45/7. All of those with what in front of them? Plus or minus, yes? I got lazy and didn't say it, but okay.
Could you plus or minus parentheses your answer, or do you have to put plus or minus in front of every single one?
Technically, you need to put plus or minus in front of every single one. If you want to be guaranteed to get your credit, say come test time, I would encourage you to put plus or minus in front of everyone, just so I don't have to make that judgment call.
Wait, so did you say that Thomas did make you write those aloud?
No. Savas will give you multiple choice, and yeah, their list will be like 1, -1, -3, -3, -5. Like they list them without the plus or minus. But here's a perfect example of be thankful Savas doesn't make you type these all out, right?
It's so bad.
It wouldn't have been so bad on the last one, but this would have been.
I'm
Annoying.
sure Thomas would give you one long one.
Yeah.
Like,
Okay, we have the basic idea of how PRRs work, yes? Okay, so moving in to the next section then. We're going to use PRRs to start these problems. Because on these next problems, they ask us to find all complex roots. Okay, so PRRs finds possibilities. And I think one thing I didn't think to mention here, so for instance, on this first example, or even this one we just did, how many total roots would there actually be? 3. There'd be 3 solutions. Did we list more than 3 possibilities? Just a smidge, right? So with that in mind, it finds more possibilities than what actually work, okay? Here, they want us to find all the ones that work. And now when they say all complex roots, keep in mind in this scenario, they're referring to complex to mean all numbers, where it can be real or imaginary. Because a plus bi, if that b is 0, that's a real number. If b is not 0, it's an imaginary number, right? So we're talking about all possible answers, real and imaginary. Now, and then we're going to write this in factored form. With that in mind. Okay. They're not giving me a nice neat graph like yesterday, are they? Like the last time they gave me a graph to tell me where to start. We don't have a graph to tell me what to start. Technically, well, okay, so we need to list our PRRs. That's what we're going to start off doing. So I'm going to call this step 1. And we're going to find our PRRs. Okay? Now, think about this. PRRs, just like what we did on the last problem. Factors of what on top? The constant, which is -2. So on top, I'm going to say factors of -2. What about on bottom? Factors of what? Of 3. Because 3 is my leading coefficient. Okay, well here's the nice part. They didn't make us find a bazillion of them. What are factors of 2? 1 and 2. So I'm going to say plus or minus 1, plus or minus 2. Denominator. What are factors of 3? 1 and 3. So plus or minus 1, plus or minus 3. Now, in this problem, in a way, I get it if you stop right here. Okay, here's the deal. We're not just finding PRRs on this problem. So if you opted to kind of leave it like this and just look at your answers from here, you could. Personally, I'm going to encourage you to write them out. So let's write them out. Start by putting everything over the 1. So 1 over 1 is 1. 2 over 1, plus or minus 2. Then we'll put everything over 3. 1 over 3, plus or minus 1/3, and 2 over 3, plus or minus 2/3. Right here, these are my PRRs. They are my possible rational roots. Are they all going to work? No. Okay, only a small handful are going to work. But those are your possible rational roots. And that is your step 1. Now, after you find your possible rational roots, we have to narrow it down and find which ones do work. Now, officially, I'm supposed to tell you to test all of those. Okay? And when I say test them, think synthetic division. That we can take, what do we have, all 8 of these, and test them and see which ones work. In other words, use synthetic division, see which ones give me a remainder of 0. Okay? Now, it's only 8. It wouldn't be horrible, but what about like the one up above when we had, what, like 12 possibilities? Actually, it'd be more like 24 possibilities when you include the plus and the minus. Okay? That would be a lot crazier. So, here's the deal. Well, I could tell you to do that. I can't give us a shortcut. Okay? Yesterday, they were giving us a little graph to look at, weren't they? And you were able to pull which ones and see. So what I'm going to suggest you do is I'm going to suggest you graph this. And I don't want you to actually like find them on there, but I'm going to suggest you graph this and just kind of peek at it and say, okay, are any of these looking to be zeros? Okay, so keep this list in mind. We had 1, 2, 1/3, 2/3, plus or minus both. Excuse me. How do we graph things in here? We use what? How do we normally graph stuff? Desmos. Okay. So we normally graph stuff with Desmos. So you would go into Desmos and you would type it in. Now, you can pull out Desmos if you want, or I can shortcut it for you because I already typed it in. Here's that first one type. Okay. We have a list of like 8 possible rational roots. I want to know which ones we think will work. And that's without like touching the graph and like finding the values, but just eyeballing it. What would you guess those numbers are? Check again. And where are we looking at on this graph, by the way? Where the graph does what? Crosses the x-axis. Now, I'm seeing some squinting. Does that mean part of the issue is this graph is too small? Yeah, and I can't zoom in. What I will say is when I zoom in, the graph was no longer counting by ones, and it was driving me crazy. But, okay, we zoom in there.
Oh, so 1 and that looks like a square. -1.
Okay. Does this look like -1? Okay, -1. This guy, does it look like a whole number? No, but did we have some fraction options on our list? What's it look like, maybe? Yeah, because 1 is over here, yes? And so if you're going 0 to 1, this is past the halfway mark, so maybe 2/3. Okay, now in all honesty, yeah, you could touch it, you can find out for sure, but that's not what this is about to me. This is about, okay, peek at the graph, oh, looks like -1 and 2/3. Let me go back and check them. Okay, and you'll have to check them regardless because we need the results. So, the note I'm going to write here to my future self is that we checked the graph on Desmos for PRRs, and now we're going to try -1 and 2/3. So I'm going to write myself a note to check graph on Desmos, and then I'm going to try, based on looking at Desmos, I'm going to try x equals -1. And then we're guessing that other one is 2/3 based on our fraction choices here. Does that make sense? Now, what is the whole point of looking at Desmos? Now I don't have to try all 8 of these to find what works. Okay? And here's the other deal. Are these the only 2 solutions? They're the only 2 visible solutions we have, but how many total solutions are we going to be looking at? Should have 4. So that means if only 2 are showing, the other 2 are imaginary. Okay, so let's set up synthetic division. I personally am going to take the -1. I feel more confident about the -1. It's a nice, neat number to work with. What list of numbers go beside -1? 3, 4, 2, -1 and -2. Did you check? Are all your place values covered? Okay. And we know how to do synthetic division by now, right? I'm going to drop my 3. -1 times 3 is -3. Bounce it back up. And now I'm going to add. 4 plus -3 is 1. Multiply. -1 times 1 is -1. Add. 2 plus -1 is 1. Multiply. -1 times 1 is -1. Add. -1 plus -1 is -2. Multiply. -1 times -2 is +2. Add. -2 plus 2 is 0. Guess what? What am I going to say about that 0? That's good news, yes? We want a remainder of 0. Okay? And what that tells me? -1 works. Okay? We were pretty sure looking at the graph -1 worked anyways, but now that is confirmed. So, a couple of things. First of all, our job is to find all the roots. It is also in the end to write it in factored form. Well, just to kind of get ahead of the game, what is -1 as a factor going to be? It's going to be x, I'm going to scoot that over a little bit, sorry. X minus -1, or in other words, x plus 1, yes? That's one factor I know. Now, this right here, the 3, 1, 1, -2. Yeah, we could write that as a factor, but here's the deal. Do I have more zeros to try? Yeah. So we're going to now try the 2/3. When we try the 2/3, do I want you to go back to the original list of numbers? No, and I demonstrated this yesterday. I want you to use this new row of numbers. Okay? So now I'm going to put 2/3 in my box, and some of you are like, oh my goodness, you're going to make us work a fraction? Yeah, but to be honest, the fractions usually work out pretty nicely. Now, the key is The row of numbers I'm going to use is the row of numbers that I just created. So we're going to use 3. Ooh, that was weird. 3. There we go. 1, 1, -2. Okay. Synthetic division, are you with me? Drop the 3. What is 2/3 times 3? 2/3 times 3? 2/3 times 3 over 1, what happens? 3's cancel, and 2/3 of 3 is 2. So 2/3 times 3 is 2. Add 1 plus 2 is 3. Oh, hey, guess what we're doing again? Multiply. 2/3 times 3 is, guess what? Still 2. 1 plus 2 is 3. I'm feeling a little repetitive. Guess what 2/3 times 3 is?
2.
Still 2. And -2 plus 2 is 0. Okay. Good news. My 0 worked, yes? Depending on what they want, and I need to look this up before tomorrow, I guess, because I don't remember. If we think about this as a factored form, this is 2/3. So one way to think about it would be x minus 2/3. I need to look up and see. I have it that way in my notes, and I don't remember if that's how they want us to leave it or not. So I need to check that for tomorrow, see if it matters. Okay, guys. We know our 2 real zeros. What we need is our other 2 zeros. In order to find those zeros, guess what? We're going to have to use that result. And we're going to have to solve it. What does that 333 represent? Represents 3 what? X squared. Do you need to go back and count? This was 3x to the 4th. So this becomes 3x to the 3rd, which makes this 3x to the 3rd, which makes this 3x to the 2nd. Sound familiar? I've gone through that multiple times with you. This is 3x squared plus 3x plus 3. At this point, that is my other factor. So in terms of factored form, we have our factors, the x plus 1, the x minus 2/3, and the 3x squared plus 3x plus 3. What we need to figure out, and this is what I have called in my paper our last step, step 4. We need to find our answers. We need to find our other 2 answers, which requires taking what we have left here, 3x squared plus 3x plus 3, and setting it equal to 0. Okay? Any thoughts of how to do that? Okay, try factoring, yes? Now if we try factoring, could we get that 3 out of there? Would that be helpful also? Okay, so if we think GCF, is there a GCF we could get out of there? We could get that 3 out of there. And here's the deal. Is this equal to 0? If it's equal to 0, technically we can divide it out altogether. Because we can divide the other side by 0. We can only do it because it's a number, but it works. So if we divide that 3 out of there, we now have x squared plus x plus 1 equals 0. Okay. GCF. Any more factoring? You would have to have something that multiplies to be 1 and adds to be 1. Well, 1 times 1 is 1. And 1 plus 1 is 2, or 1 minus 1 is 0. Do 1 and 1 equal 1? terms of adding or subtracting? No. Factoring's not going to work. Guys, these aren't going to be real answers. I could have told you factoring's not going to work. It was good to get the 3 out there. That makes life better. What's plan B when factoring fails?
Cry in a corner.
What did you say?
Cry in a corner.
Cry in a corner. Well, I'm looking for a little bit better option that could earn you some points.
Sympathy points?
Yeah, no. Blue formula paper. What was on that the other day that we used just the other day?
Oh,
The cry in the corner formula, maybe? AKA quadratic formula? Is it still around, guys? It is. It is. Okay, let's get this quadratic formula and bust it out. Okay. What now?
Room.
Sorry. I mean, you know, go into B sum, you'll just have to adjust B tomorrow, I guess. But
B doesn't have a
I know. I don't know. Do the best you can. A post-it note that you stick on there, maybe?
Yeah. Sure.
Okay. Quadratic formula. Negative B. What is B? What are A, B, and C? All of them. 1, 1, 1? Yes? So negative B, negative 1, plus or minus the square root of B squared, so 1 squared, minus 4 times A, which is 1, times C, which is 1, all over 2A, which is 2 times 1. Come on, guys. You got to be able to do this quadratic formula on your own without me leading you. Negative 1 plus or minus. Okay, 1 squared is 1 minus 4 times 1 times 1. So 4. 1 minus 4. Negative 3 all over. 2 times 1 is 2. Okay. What do we know about the square root of negative 3? Square root of the negative is a what out front? An I. Do we know the square root of 3? No. So I'm going to write this as negative 1 plus or minus I square roots of 3. And I just have it all over 2. Okay. Those are the roots we just found, yes? What did we already know, folks? What did we already find that worked? 2/3 and negative 1. So also over here, I'm going to say negative 1, and I'm going to say 2/3. Did I just give 4 solutions there? I did. A plus or minus is 2, and then there's 2 more reals. So right here, folks, these are my roots. These are my roots or my solutions. It asks me to find all complex roots. Real quick, it also asks me for factored form. Okay, I'm going to squeeze my factored form in up here. And with factored form, what factors did we find? We found x plus 1. We found, I'm going to leave it as x minus 2/3 because that's what I have in my notes for right now. And we found the 3x squared plus 3x plus 3. Your factored form would look something like that. Okay? And I'll do a little bit more checking into that before tomorrow about what Savas wants. Okay. 3.5. If you didn't get it done, get it done. Okay, 3.6 is going to be out there. I wouldn't worry about it too much, although you could delve into it a little bit. Okay? Have a good day.
Have a good day.